Hello बच्चों, let's read the question. So the question here says which of the following statements are correct. हमें यहाँ पे 4 statements दी गई है, इनमें से कौन सी correct है ये हमें बताना है. ठीक है, तो फर्स्ट स्टेटमेंट यहाँ पे है मोनोसेकेराइड्स आर ऑप्टिकली एक्टिव पॉलीहाइड्रोक्सिल कार्बोनिल कंपाउंड्स. ओके, तो जो भी मोनोसेकेराइड्स कंपाउंड होते हैं, फॉर एग्जांपल हम लोग यहाँ पे ग्लूकोज ले लेते हैं, तो ग्लूकोज में यहाँ पे OH आएगा, यहाँ पे OH आएगा, and then we'll be getting OH over here and here OH over here. Okay, so this is a D-glucose. Okay, so here D-glucose means the OH will be over this, means right side. Okay, so this is a D-glucose. So here they are said as optically active polyhydroxy carbon. Yes, they are optically active. For example, here we'll be taking CH2. Here we'll be having C double bond O, and so these are optically active hydrocarbons. Okay, so now we here the first one will be correct. Now second one, we are told that fructose does not react with Fehling solution because it's a keto. Now let's see if it reacts or not. So let's draw here. So here we'll be getting CHOH thrice and CH2OH. Okay, so this we can see. So here this, so we'll draw it into the cyclic structure fructose. So here it will be something like this, double bond O, and here will be, okay, here we will be having OH group, something like this, and then here it will be like this. So here we'll be having OH group, here we'll be having H group. Okay, so what happens here is when OH minus OH negative will act over here, and the H2O, that is water, will be removed. Okay, so here there will be, this compound is known as alpha hydroxy ketone. Okay, alpha hydroxy ketone, keto. Okay, this is the alpha hydroxy ketone. Now what happens over here is, what happened here is when this is reacted, this will be converted into a product something like this. Here we'll be getting O. So see, here it will be removed. Why? Because this when this will be reacting over this, so this double bond will shift over this in order to increase the density. Okay, so here the compound will be something like this. Here will be having O, here will be having OH, and here will be having a double bond. Okay, so now what happens when H2O will be added over here? So we get a compound something like this. Here we'll be getting OH, here we'll be getting OH, and here we'll be getting R group. Then afterwards again this compound will be shifted. Okay, again this compound will react over here. Here we'll be having OH group, here we'll be having double bond O, and here we'll be having R. We can write R over here. R is any other group. So here we'll be having compound like this. Okay, so now what happens over here is, this is the compound we get over here. Okay, so here it is said that fructose does not react with Fehling solution because it is a keto, but it is a keto and it reacted with this Fehling solution. So here the option number B will be incorrect because it is reacting very well with the with this Fehling solution. Okay, so option number B will be incorrect. Now option number C, it is said that alpha D glucose and beta D glucose are anomers. So yes, anomers, because what are anomers? First of all, so anomers are the compounds where the C1 carbon atom, that is alpha carbon, does not look same, and other all the configuration will be same except this C1 carbon. Okay, and alpha D glucose and beta D glucose are anomers because they show exactly same configuration, and first carbon, this carbon one, only carbon one differs. Okay, so this will be the anomers. So here now we'll see the now we'll see D glucose and D-Mannose are epimers. Okay, so now let's see. Epimers means the OH group is present in the second. Now D glucose and D-Mannose, let's draw the structure of D glucose and D-Mannose. So here the structure will be something like this. See, this is the D glucose. Here we'll be having CHO group, and here we'll be having 1, 2, 3, 4, and here we'll be having CH2OH group. This is known as D glucose. Okay, here we'll be having OH group, here we'll be having OH group, here OH group, and here we'll be having OH group. Okay, 4 OH group, 1, 2, 3, 4. Here also we'll be having an OH group. Okay, so this is known as D glucose. Now D-Mannose will be something like this. Here we'll be having CHO group, and here it will be something like, here we'll be having OH group, here we'll be having OH group, here we'll be having OH group, and again here we'll be having OH group, and here at the bottom we'll be having CH2OH group. Okay, so this is known as D. This is the D glucose and this is the D-Mannose. Okay, here I'll be writing D-Mannose, And here I don't have space. Let's write D-glucose over here. Okay, so this is the D-glucose compound. Now, in D-glucose and D-mannose compound, we can see the OH bond. Okay, so the second OH bond. Here the second OH bond will be same. Okay, here it will not be. Okay, so here the second OH bond will be same over here. So it is known as the D-mannose. D-mannose. Okay, here in first also it will be OH will be in this side. Okay. So D-glucose and D-mannose both have the OH bond over here. The second OH will be in the same direction, that is over here. Okay. So such compounds are known as epimers of each other. So D-glucose and D-mannose are the epimers of each other. So this will be also be correct. Option number C will also be correct, and here option number A will also be correct over here. Okay. These three sentences are correct. Okay. Option number A, C, and D are correct. Okay. This was the correct state. These are the correct statement. I hope the concept is clear.